To continue our discussion on compound interest, I'd like to develop a formula for the amount of money in some account earning some kind of annual interest rate that's fixed ahead of time, just like we did for simple interest. And so you'll find out that actually the derivation is pretty straightforward once we understand what compound interest really is. Recall that compound interest is just interest earned not only on the principal, but also on the interest earned. Okay, so in other words, we're earning interest on the entire amount that was in the account the previous step, okay, or the previous time period. Okay, so again, to that end, let R be the annual interest rate as usual, which is fixed ahead of time. And after 1 year, the amount that's in this account, I'll call it A, again for the amount that we expect, A sub 1 for after 1 year, is equal to, well, it's just going to be the principal, which is the amount we started with, plus some interest earned on that principal, right? So P plus R times P. R is the interest rate that we're earning, okay? So as usual, like we talked about for simple interest, I can factor out the P, okay? So it's 1 plus R times P. Now for the second year, after 2 years, A sub 2 is going to be, well, again, the amount that we're getting is not only based on the principal, but we're earning some kind of interest on the total amount that was in the account from the previous year. Okay, so we're compounding, or we're calculating interest every year, recalculating the interest. So in other words, the amount in account after the second year is going to be the amount that was in the account after the first year, plus some interest that's earned on that amount. Okay? This is a far more common way of computing actual interest, because we're earning money on the amount that was in the account from the previous year. Okay? And so, again, if I replace A1 with this formula that I developed from simple interest, basically, it's going to be P times 1 plus R times P times 1 plus R. Okay, I just replaced A1 with this formula that I have up here. And you can see that, in fact, there's a common term, which is P times 1 plus R, before the plus sign, and also after the plus sign. Right? So I can factor that out as well, if you recall from algebra. So P times 1 plus R can be factored out of a 1 here, plus there's an R left over on this term. Now, when I have two copies of the same thing, it's the same thing as squaring it, right? So I can write this as P times 1 plus R quantity squared. Okay? So that's the amount in the account earning some R annual interest rate after 2 years. Okay? How about after 3 years? Well, I'll call it A sub 3. And that's going to be, again, I am earning interest on the total amount that was in the account just from the previous step, because I'm computing interest every year. It's a compounding period of 1 year. So in other words, A3 is going to be equal to the amount that was in the account from the previous year, which is A2, plus some interest that's earned on the amount that was in the account from the previous year, which is, again, A2. And so, again, if you factor out this the same way, let A2 just be this quantity here. I'm going to factor this out just like I did for the previous step. You should double check that this is true. But you get something like this. You get P times 1 plus R cubed. Notice there's a relationship between this 3 here and this 3 up here. Okay? And you'll see that the pattern will continue. Right? As you go on and on, there's a pattern emerging here, which means there's a formula emerging. So after T years, if I have this amount in the account, this principal that's sitting in the account after T years, and I'm earning interest on every step, every subsequent step, I'm earning interest on what was in the account the previous year. Right? If that's true, then A sub T is going to be the amount that was in the account the previous year, which is just A sub T minus 1. You choose your T, plus some amount that's earned on the previous step. Okay, so it's R times A sub T minus 1. And that's going to turn out to be, once we sort of put these values in like we did before, same kind of procedure, you're going to get this formula. You're going to get P times 1 plus R to the T power. Okay? So in other words, the amount in the account after T years is equal to the principal multiplied by 1 plus R raised to the T power. Okay? So certainly you're going to earn more after T years than you would if you had simple interest, right? If it was only simple interest that was being computed. Because we're earning interest not only on the principal, but also on the interest earned. okay, on the total amount that's in the account from the previous year. Okay? And we'll learn this very soon, but it turns out this is compound interest that's compounded yearly. So the compounding period is just 1 year, which means that we're computing the interest every single year. And that's what we mean by we're computing the R on the previous step. Right? That's what we mean by this. Okay? So in other words, if you think about it, the interest rate is fixed from the very beginning. That's fixed. That's a fixed amount. The amount of money that you put into the account, the principal, is also fixed. Okay? Provided you don't add any money in as you go along, then what's going on here is the only variable in this equation is really t, right? That's the unknown. That's the amount that we have in the account for however many years. So in other words, what I'm trying to say is that this formula is really a function of t because the rest of the terms are constant. So I can write this as a as a function of t is p times 1 plus r to the t, because of course p and r are constant, are fixed. Now, if you recall from your days from algebra, this is really an exponential function, right? Where this is some coefficient here, and this 1 plus r is really the base of the exponential. Okay, so this is the amount in the account using compound interest after t years, earning some r as an annual interest rate with some principal that we started with, is really an exponential function. It's growing exponentially, the amount in the account after t years. Okay? Usually, in many real situations, the interest rate is pretty low, and so even though this is growing exponentially, it's kind of a slow growth exponential function. Okay? But it's still an exponential function. And again, this is the amount that's in an account after t years when I'm earning compound interest, or in other words, interest is being compounded once per year.